We're missing dos. Okay. So we are going to start with this formula. It is reviewed from something we've done before. The formula for compound interest. So just to review what everything means, A is the final amount, the final worth, whether this is an investment or whether it's a debt that you're paying back, like a loan. Whatever it is, this is the final amount. P is the principal. That's your original money borrowed, loaned, invested, depending. And then you have 1 plus R over N. R is the annual percentage rate, so that's going to be a decimal. N is the number of times it's compounded annually. And then T is the time in years. So it says an investment with an initial value of $5,000 is compounded quarterly at 3% APR for 8 years. How much is it worth at the end of 8 years? So this part we've done. So we're going to start with that. So we're going to use the formula. 5,000 is the principal. It's always 1 plus. The 3% APR we have to change to a decimal, so 0.03. And then if it's compounded quarterly, how many times a year is that? 4. So you divide that by 4. So they're basically taking the interest and dividing it into those 4 time frames that they're adding interest. And then you have N times T, which would be 8 is... and so that'd be 4 times 8. And that comes out to 32, and that's the total numbers of times that the interest is getting added on. And so what we're actually going to put in the calculator, I'm going to go ahead and change that to 32, and then you can type the whole thing in. You could type this middle part in, but sometimes you get weird decimals, so I like to just type it all in at once. So 5,000 parentheses, 1 plus 0.03 divided by 4, close parentheses, to the 32nd power. So it looks like that. Hit enter, and this is talking about money. So how many decimal places should we have if it's dollars and cents? 2. Very good. So the 5 is going to round up to 5 6. So when I put this down, I'm just going to put it over here, $6,350.56 is the answer. So that's the part that we have done before. Then it says, how long will it take for the investment to be worth $12,000? We've done these kinds of questions where you took it and graphed it and had to figure out how long it was going to take. We're going to use algebra and logarithms to solve it this time. So what we're going to do is we're going to put 12,000 in as the answer. We'll put 5,000 in as our starting point. 1 plus 0.03 over 4. And what we don't know this time is the time, but we do know it's 4 times a year. So 4 times however many years gives us that equation that we can solve. So I'm going to go through this and show you how you can solve it and put it in the calculator. So this is really just one number raised to the 4t power. When you're solving an exponential equation, we want to get that part with the power by itself. So first we're just going to divide both sides by 5,000. And you could go ahead and do that. It comes out 2.4. If you get a strange decimal, don't round it off. Keep it on your calculator for future use. That way you don't end up with something strange happening. And for this one, I'm going to go ahead and change this number because I think it might make sense. If you just do 1 plus 0.03 divided by 4, it comes out 1.0075. And then we're taking that to the 4t power. So we did a lesson on solving exponential equations using logs. So what you do is you put this into log form. So I'd have log of base 1.0075 of 2.4 equals 4t. And then we can solve for t. So this part, you can do the change of base theorem. Log of 2.4 over log of 1.0075. And whatever that is equals 4t. So let's put this onto the calculator. So we'll put in log of 2.4 divided by log 1.0075. And we get this number, but that's equal to 4t So you could write down 117.166 whatever equals 4t, and then you're going to divide by 4. You already have it. You guys picked it up ahead of time.
Are you talking to me?
Yeah.
Yeah, I lost it.
Oh, it's online.
Is it?
Mm-hmm.
Both of those?
Mm-hmm.
The two?
Mm-hmm.
Cool.
Okay, so we get about 29.3 years. So that's how long it's going to take for this investment of $5,000 to get to $12,000. So if you put some money in, that's a really long time. But if you put an investment in, say when you're 18 and you're pulling it out when you're 48 and you've made that much interest, that's not so bad. So start thinking about investing now, I guess. All right, so let's go through the next part. I'm going to zoom back out a little bit so we can see the whole problem. You put $400 into a savings account 5 years ago. If it earned 1.5% APR, which actually would be pretty good, compounded quarterly, which is how they're usually compounded, and you did not make any withdrawals, and they're also assuming you're not making any deposits, how much is in the account now? So let's do that. So $400, 1 plus, and the interest rate, 1.5 would be 0.015. It is compounded quarterly. They're not always quarterly, but if it's quarterly, it's 4, semi-annually is 2, monthly would be 12, so just how many times in a year. And then we're doing it 4 times a year for 5 years. So 4 times 5, I'm going to go ahead and just put 20. This number is how many times they're adding interest. It's basically how many times a year is it getting compounded times the number of years. So this was 4 times 5. And you can go ahead and put that into the calculator. It rounds off to $431.09. So it's not a huge gain. You just let it sit there. It only gained $31, but it's better than not gaining anything. And usually with a savings account, the more you have in there, the more you're going to make. And if you add a little bit every month, it'll go up faster. All right, then it says, how many years in total will it take for your savings account to reach a balance of $1,000? So 1.5% APR is not great, but let's say you just thought you were going to do that. So we're going to make 400. Actually, 400 is the final answer. Let's put 1,000 over here. Or do you guys like having the number by itself on the other side? We can do it that way. Let's do it that way. So let's just set up this part. We'll start off with you starting with 400. And if I do the 1 plus 0.05 divided by 4, I get 1.00375. I'm just going to go ahead and do that. And that's 4 times a year for an unknown number of time. And then that equals 1,000. So I'm just going to set it up with it on this side this time. I think that'll help you guys when we put it in log form. All right, so we need to get the part with the power by itself. So you divide by 400, divide by 400. That's going to give me 2.5. I've got 1.00375 to the 4t power. Okay, so the way that you get rid of powers to solve equations is by putting it into log form. So I'm going to have log, what would be the base? 1.00375 of 2.5 equals 4t. And this number we can do using the change of base theorem, which was that thing we said, oh, if we put it in the calculator, it's going to be log of 2.5 over log of 1.00375, and that equals 4t. So if you put all of that in, so let's do log of 2.5 divided by log of 1.00375. This is the number that I get. So it's about 244.80. That equals 4t. So you can solve it by dividing both of those by 4. I'll just put divide by 4 in my calculator, and it comes out about 61.2 years. Wow. So you're going to be pretty old by the time that savings account reaches 1,000, which is why most people Most people do not use a savings account to save for retirement. We don't use savings accounts for that sort of thing. It is better to put it into mutual fund or something that's going to make a little higher percentage. Okay, so let's go down to the next part. So we're going to look at the formula for appreciation and depreciation. Appreciation means that things are gaining value. If you buy a house and take care of it, generally prices go up. And usually if you turn around and sell it later, you usually can get more out of it than what you paid for it if you kept it nice. Depreciation is like when you drive off the lot with a brand new car and it's immediately losing value because it's got because it's used. All right, so this is the formula. It's based off of the same basic formula as compound interest, except that we're not compounding it quarterly. It's usually just like an annual thing. So A is the final amount, P is the original amount, R is the rate of increase or decrease. If it's appreciation, you do plus. Depreciation is minus. Time is T. Okay, so it says you're considering buying a new car that has a list price of $23,000. Kelley Blue Book says that in past years, this model has depreciated at a rate of 20% per year. How much will the car be worth in 3 years? When will the car be worth $5,000? So first we're going to learn how to use the formula. So we are starting with $23,000. And then you start with 1. That 1 represents the 100% that you're starting with. And then we're subtracting from that 20%, which would be 0.2. And we're leaving it in for 3 years. So this would be a power of 3. So if you subtract 1 minus 0.2, that leaves you 0.8. Essentially, what they're doing is finding 80% of what's left of the value each year. That should make sense, I hope. They're finding 80% after 1 year, 80% after 2 years, 80% after 3 years, because it's lost 20%. If you put all that in, after 3 years, it's worth $11,776. I think I rounded that off, but it's pretty close. Okay? So that's how the depreciation works. You use minus. If it's appreciation, you use plus. Then it says, when will the car be worth $5,000? So this is,
once you left it.
and so we're going to start with the $23,000 that it started with, except I'm going to go up a little bit. I have space. I'm going to use it. $23,000. We know it's retaining 80% per year, but we don't know how many years it's going to take before it equals $5,000. So we're going to set it up like that. So how do we solve something that looks like that? What do we do first?
Minus 23,000.
Maybe not minus, but divide.
Oh.
Since it's times, we want to divide, which is repeated subtraction.
You weren't answering the question, Parker.
Okay, so 0.8 to the t power. And I'm just going to cross off some zeros here, and I'm going to leave this as 5/23 because that's a weird decimal. But I did reduce it. Like, you can just divide both of those by 1,000, and that makes it look a little easier. And then we can write it in log form. So log base 0.8 of 5/23 equals t. And then the change of base theorem says we can break that apart and do log of 5/23 and divide that by log of 0.8, and that'll give us our answer because it was just t, it doesn't have anything else. It comes out about 14.2 years. So you've got a little while. It doesn't, when people think when you're taking 20% off that it's going to be 20%, 20%, 20%, 20%, and after 5 years there's absolutely no value. But it's taking off 20% of the value at the end of the previous year. So it's technically never going to be worth nothing. It just gets awful close after a while. Okay, so let's go down to the next one. Mr. Smith bought a house for $150,000 10 years ago. It has appreciated, it's gained at a rate of 5% per year. How much is it worth now? And when will it be worth $300,000? So he spent $150,000. Okay, And then it's appreciating at a rate of 5% per year. So I'm going to have 1 plus 0.05, or you could go ahead and change that to 1.05 if you want. And then that was 10 years ago, so we're going to do 10th power. So if you put all that in, you end up with $244,334.19. Got to keep those pennies. So that's not bad if it gained 5. Now 5% per year would be a lot. He'd have to be putting some work into the house every year, but you could put 5% of value into your house every year. You could put more than that if you redo certain.
Thanks, Realtor Jasper.
Okay, so it says when will it be worth 300,000? So we'll start with what we had, 150,000. I'm going to change 1 plus 0.05 to 1.05. I just added those together. I'm going to put it to the t power because we don't know when. That's what we're looking for, is the time. And set it equal to 300,000. And then it looks like the equations we solved in the last lesson. So our first step is to divide by 150,000. So essentially what he's looking at is how long it's going to take to double his money. Go from 150,000 to 300,000. I've got 1.05 to the t power over here.
So then log.
So then you'd have log base 1.05 of 2 equals t. So what you would actually put in the calculator would be log of 2 over log of 1.05. And it comes out roughly, I have 14.2 years again in my notes. Does it come out the same? Let's find out. Log of 2 divided by log 1.05, 14.2. So it's just coincidental it comes out the same amount of time as the last problem. Okay, I have